We are working on lesson 13 today. We are doing some subtraction. Problem number 1 says, use the standard algorithm to solve the following subtraction problems. Standard algorithm is a fancy mathematician's way of saying, let's stack our numbers to solve. So for 1A, B, and C, the only model that you need to use is your vertical form, also known as your standard algorithm. And you know what? Let's do one together right now. I'm going to start actually with this center problem because I feel like this is where we could run into our first challenge. I think you can handle A all on your own, so let's look at B. I have a rhyme that I use to remember my subtraction with regrouping rules. It says, more on the top, no need to stop. More on the floor, go next door, get some more. The only exception is when we have two numbers that are the exact same. Like, let's look at our ones place right here. And if it's helpful for you, you can draw lines in between your place values to help you separate the numbers. In our ones, we have both 2 at the top and the bottom. If I start 2 and I take away with 2, I'm left with nothing. So I'm going to put a 0 in the ones place. Let's continue on to our tens. More on the top, no need to stop. Since there's more on the top, the 4 is greater than the 2, there's no need to stop. I can keep on subtracting without any problems. 4 take away 2 is 2. But as you see, when I go over to the hundreds, there is more on the floor. If there is more on the floor, I need to go next door and get some more. I need to take a group of 1,000 away and bring it over to my hundreds place. When I take away a 1,000, I'm giving the 100s place 10 hundreds. Now I have more on the top, no need to stop. 10, take away 1 is 9. I have a comma here and a comma here, so I'm going to drop that comma down to the same spot. 7, take away 4 equals 3. And 1, take away nothing. We're going to pretend that there's a 0 right there, equals 1. So altogether, B, our answer is 13,920. Don't you just love getting free answers? Whew! That means that you are ready to go to do A and C all on your own. But let's talk about number 2 before I let you loose. 2 says, draw a tape diagram to represent the following problem. Use numbers, kind of like how we did up here, to solve. Write your answer as a statement. Check your answer. The question reads, what number must be added to 1,575 to result in a sum of 8,625? So I'm going to circle my numbers. My entire statement is a question, so I'm not going to underline the whole thing. Instead, I'm just going to go through and box my math action words, which are added. That feels important. And sum. All right, take a moment. Box and circle on your own sheet. I'm going to move on in 5, 4, 3, 2, and 1. They want us to represent these numbers using a tape diagram. Now, our final sum of the tape diagram is going to be 8,625. That's a large number. So let's go ahead and draw ourselves a nice long tape diagram to represent that number. I'm even going to make it as large as my question. Take a moment to do the same thing. This entire tape diagram is worth 8,625. Either above or below your tape diagram, can you show that the whole bar is worth that much? Now, part of that tape diagram is 1,575. That's not even close to being halfway, so I'm going to draw like a mark maybe right around here. Let's label this small piece 1,575. 575. So what's our job today? Our job is that we need to figure out what this piece is right here. Now, I know that our word problem is using words like added and sum, and that makes our brain think, oh, we're going to do addition today. But when we're doing addition, a lot of the time that means we're ending up with a larger answer. But look at this tape diagram. Do we want our answer to be larger than the entire piece, 8,625? No, we want it to be a number that's smaller than that, which means that today we're going to be doing the same kind of subtraction that we did up here. When we set up our standard algorithm, we're going to put our larger number on top and our smaller number on the bottom. I'm going to pause and do it on my screen. You pause this video and write it down on your exit ticket, and I'll see you in about 5, 4, 3, 2, and 1. If your number sentence looked like mine, fantastic. Congratulations. You are a standard algorithm genius because this is exactly what we are looking for. We are now going to solve by subtracting the bottom number from the top, but you're going to do that part on your own. The last step I'm going to help you with is writing your answer as a statement. What do these numbers mean in our word problem? Here is a fantastic sentence starter to put in front of your answer. We have to add blank, and that's where your number would go, because that's how much you have to add to get a sum of 8,625. All right, now it's your turn. Make sure you have the same notes on your exit ticket and take a picture when you're done. Good luck.